Okay, in this section we are going to define and more about rational numbers and irrational numbers now. So irrational numbers are numbers that can be written that cannot be written as a fraction. Any number that is not a perfect square root is irrational. And when you square root a whole number, like square root of 5, whenever you square root whole numbers like that and you get a decimal, look at the decimal, make sure nothing is getting repeated. That will be an irrational number. So let's get into it. Circle all rational numbers. In your calculator, if you type in the square root of 9, you get 3. That is a rational number. If you type in the square root of 3, you get about 1.7, and it goes on forever. That is irrational. Square root of 8, you type that in, you get about 2.828, blah, 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 blah. That is irrational. Square root of 7, you get 2.6, and it goes on forever. That is also irrational. Square root of 5, you get 2.2, and that goes on forever. That is irrational. Square root of 4 equals 2, which is in fact rational. Square root of 6, you get 2.4494, blah, blah, blah. That is irrational because it goes on forever and it never repeats. Another number that goes on forever, never repeats, is the square root of 2. Next, we want to circle all the numbers that are irrational. So the square root of 25 is just 5. That is rational, so we're not going to circle it. Square root of 50 gives me 7.07. Notice in your calculator how that goes on forever and it never repeats. That is irrational. Square root of 125 is a number that goes on forever, never repeats, therefore it is irrational. Next, we want to circle all the numbers that are rational. This first decimal, it terminates, it stops, therefore it is rational. This decimal we can write with the bar above it as a repeating decimal, therefore it is also rational. Right here, this decimal does not terminate. The dot, dot, dot at the end means it goes on forever, and it does not repeat. I cannot put a bar over any numbers, therefore it is irrational. Right here, I get 1, 2, 3, 4, and looking at the dot, 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 that is going to keep repeating, so I can put a bar above the 1, 2, 3, 4, so therefore it is rational. 8.083 with the bar above it makes that also rational. Here I want to circle all irrational numbers. So 3.202, 002, 0002, this one is irrational. It does not terminate, and it does not repeat. Here I get 3.213, and I can put a bar over top, therefore it repeats, so it is rational. And the next one is a pattern. It is not a repeating decimal, and it does not terminate. So next we can use our number charts to help us that we can find that were given to us. So the number 15, all of these numbers that we go over are going to be real numbers. So we can always check real. Next, a number is either rational or it is irrational. 15 is a rational number. 15 is also an integer. Integers are positive and negative whole numbers. So numbers that are not fractions, all right, not decimals. Whole numbers, you start at 0 and you count up. So no negative numbers, no decimals. So you count up. Natural numbers, if you naturally start counting, you start at 1 and you count up. Eventually you will count to 15. So natural number is the lowest subgroup for 15. Negative 1.232, that is a terminating decimal. And remember, all terminating decimals are rational. Next, if we substitute or plug in our calculator, the square root of 45, we get 6.7 dot dot dot. It does not terminate, it goes on forever, and it does not repeat. We can't put that bar, therefore it is irrational. If it is irrational, it is nothing else. We don't have to worry about it. So 121 divided by 35, that is a fraction, which is rational. The negative 1 times the square root of 16 gives me negative 4, which is a rational number, and it is also an integer. Notice whole numbers and natural numbers do not have negative numbers in them, so therefore we are done. 21 divided by 3 equals 7. Okay, 7 is rational because it is an integer, it is a whole number, and it is natural. You can count to it. All these nice numbers like this, 7, negative 4, those are rational as we learned in the last section, and then integers as well. And what are all possible names for the number 1 and 2/9? Well, we know all numbers are real. After real, we have to choose between rational and irrational. Since it is a fraction, it is rational. And then it is a fraction, therefore it is not an integer, because integers do not include fractions. So therefore, we are done.